Hello, everybody. I am obviously not here today for math, so what I want you to do is get the lesson anyways. So I'm going to walk you through the lesson through this video. As you enter the room, I would love for you to grab your workbooks. Once you've gotten your workbook, if you would make sure you tear out pages 155 to 161, label the next page in your notebook, page 20, calculate and interpret the average rate of change, and then complete the warm-up on page 155. Once you've completed the warm-up, you can come back to the video and check your responses for the warm-up. So click pause and then come back once you've completed the warm-up. The warm-up is about bus drivers practicing the routes before the school year starts. And the first question wants us to describe the route the bus took in relation to miles over time. The second question wants us to use two different points to find the average speed of the bus in miles per hour. And then the third question is asking about different factors that affect the bus ride. So for the first question about how time increases on the graph, you'll notice that also the distance increases. So I said that as time increases, the bus travels at a farther distance. And also there are different parts in the graph where I see steeper portions, and that represents times that the bus is able to travel faster. In question number 2, it's asking us to use 2 points to find the average speed of the bus. And because I know those 2 points, I can label the first one as x1, y1, and the second point is x2, y2. I can then use the slope formula to determine what the average speed is of the bus during that portion of the graph. So I end up with 30 over 60 minutes, and 60 minutes equals 1 hour, so I know the average speed is 30 miles per hour. In question number 3, it's asking about different factors that affect the average speed of a bus. And there's a ton of different factors that impact how quickly a bus can travel down the road, depending on stoplights, traffic, the time of day, and things like that. Just a reminder, when you're given 2 points, you can use the slope formula to find the slope or the average rate of change. And in today's lesson, you're going to be given specific boundaries for some of the questions, and you're going to use those values as your x1, y1, and x2, y2 values. So if you would now turn to page 156 and look at example 1, I want you to take a minute, so read through the question and answer it, pause the video, and then come back to the video after you have answered the question. The first part of the question asks about determining the new depth of the submarine. When we look at the information we are given, we know that the submarine is starting at a depth of 150. So that means it's actually negative 150 feet below sea level. And at 45 seconds, it's negative 1,800 feet below sea level. So for the first question, the new depth of the submarine is negative 1,800 feet. In the second part of the example, it wants us to calculate the rate of change. So when I'm looking at the rate of change, I'm going to take the negative 1,800 feet and I'm going to subtract the negative 150 feet for the depth below sea level. So I've taken my y2 subtracted y1 and put that over x2 minus x1. When I solve that, I get a rate of negative 36.6 feet per second. All right, take a minute, read through example 2, pause this video, and then come on back after you have tried to solve number 2. In this second question, the graph gives us information on the distance in miles along the x-axis, and then the miles that Teresa travels along the y-axis. So we're to look at the different hourly intervals to determine which one has the greatest rate of change. So when I look, the different intervals will be hours 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then 4 to 5. So I'm going to use the x and y values from hours 0 to 1 to figure out my rate of change or the slope. So at hour 0, my point will be 0, 0, and at 1 hour, my point will be 1, 2. So I'm going to use those 2 points to help me find the rate of change for the interval of 0 to 1. I'm then going to use the same procedure to find the rate of change for hours 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Then I can compare to determine which interval has the greatest rate of change. So on here you can see my intervals off to the left-hand side, and you'll notice that the interval from 0 to 1 hour has the greatest rate of change, and that means that she hiked 2 miles during that interval of time. Take a minute and solve example 3. So pause the video and then come on back once you have solved your question number 3. In example 3, it wants us to use the interval from 10 to 70 to determine the average rate of change that a person spends sleeping each night. So you'll notice on my copy that I labeled my first point at age 10 is x1, y1, and then at age 70 is where my x2, y2 came from. So I'm using those two values to calculate my average rate of change because that is the given numbers they have given to me to determine the average rate of change. So when I calculate all of that, I get that on average, a person spends 3 minutes less each year sleeping. All right, in example 4, go ahead and read through the example, pause the video, solve it, and then come on back to the video once you have attempted to solve the problem. In this question, it says to find the average rate of change over the interval -1, 0. What does the average rate of change tell you about the function on the interval? And does the rate of change for the function appear to increase, decrease, or remain the same as x increases greater than 0? So the interval that I'm going to be using, this -1, 0, means when x is -1 and when x is 0, what is the average rate of change there? So at -1, x, my y value is 4. So my first point that I'm using to find the rate of change is -1, 4. The second point that I'm going to use is 0, 1. When I use those two values to find the rate of change, I get -3 as my average rate of change. And in noticing that my average rate of change, the function is decreasing because I have a negative value. I can also see that when I look at the line. The line from left to right is going down, which means that it is decreasing. All right, last example together on page 158. I want you to take a minute and read example 5. In example 5, you're solving 3 different functions with 2 different intervals. To solve each of these to find the rate of change for each one, you're first going to plug in 2 to the function, then plug in 3 to the function. You are going to receive y values that correlate to each of these x values, and then you can use those to help you find the rate of change for each of those functions. Go ahead and solve each function f, g, and h, and then come on back and check your work with the video. You'll notice when I solved example 5, you'll see on the right-hand side my work for function f, for function g, and for function h. After I plugged in 2 as my x value into the first function, I got my y value of 8. So my first x and y values are 2, 8. Then when I plugged in 3 for my function f, I got 10 as my y value, so my second point is 3, 10. I was then able to use those 2 points, plug them into the slope formula, and get a slope or rate of change of 2/1 for function f. I followed the same steps for function g, where I plugged in 2 into the function, then I plugged in 3. When I plugged 2 into the function, I got 10, and when I plugged 3 into the function, I got 15. I then used the slope formula and got a slope of 5 for the function g. One last time, I did the same type of strategy where I plugged in 2 into function h, then I plugged in 3 into function h. When I plugged in 2 into function h, I got 16 for my y value, and when I plugged 3 into function h, I got 64 as my y value. Using the slope formula once again, I got a slope and rate of change of 48/1. After I got each of my rate of changes for my 3 functions, I was then able to look and analyze what that means. So when I look at the values, h of x has the greatest rate of change and f of x has the smallest rate of change. All right, now it's time for you guys to practice. What I want you to work on today is practice on pages 160 through 161. I will see you all tomorrow.